esteemed guests, fellow researchers, and distinguished speakers in audience of 7 Kuala Lumpur International Conference on Education, Economics, and Technology 2025. My name is Mallinder Anak Maoh, and it is my honor today to present our research on Ecopower Guardian in Mas Gading. This work was conducted alongside my esteemed co-authors Chong Man Leong and Leni Lai Melan, whose invaluable contributions have shaped this study. I would like to extend my gratitude to the organizers of this conference for providing this platform to share our work. Without further ado, let us begin. There are 105 community colleges in Malaysia. It plays a vital role in providing technical and vocational training to students and offering lifelong learning opportunities to the community. Challenges that we face in Mas Gading Community College is rising operational costs, especially electricity. The issue of awareness campaigns is ineffective due to human error and inconsistency. The Ecopower Guardian is using IoT-based automatic light control system controlled by ESP32 IoT board with timer-based mechanism consisting of predefined lighting schedules, manual override buttons for flexibility, and remote monitoring and control via the Arduino IoT cloud. Ecopower Guardian proposed an innovative Internet of Things, the IoT solutions, capitalizing on the fact that over 10 billion IoT devices are now connected worldwide. This project introduced an automatic light control system designed to optimize energy usage through precise schedulings, remote monitoring, manual control, and also bypass control. Balancing performance with cost-effectiveness, ESP32 is an excellent option for IoT devices and hence emerged as the ideal core for this project. This project was installed at Mas Gading Community College to automatically control level 2 corridor lighting and exhaust fan based on predefined schedules that consider the working hours. The systems offer dual control methods other than the predefined schedule. A control panels with 4 buttons and the indicator lights allow for manual operations, while the Arduino IoT Cloud apps provide 2 buttons for the convenience remote control and power usage monitoring. Additionally, 4 bypass buttons ensure continued control even in the case of system failure. Ensure lights are activated only when necessary, thus minimizing the wastage. Moreover, the integration of this project is not only promote sustainability by lowering concerning carbon emissions, but also serve as an educational tool fostering awareness about energy conservation among students and also staff. For problem statements, first thing is, of course, rising in the electricity bills. Number 2 is uncontrolled electricity consumptions. So therefore, to effectively address this rising electricity costs, the college require innovative solutions that manage electricity use more efficiently, ideally without the burdens of the continuous manual intervention. Okay, the objective of this research is to develop an innovative automatic light control system utilizing the IoT technology, scheduling lighting based on predefined timings, and allowing for remote monitoring and control through the Arduino IoT cloud. The second one is to reduce electricity consumptions and operational costs during office hour. And the third one is to evaluate the effectiveness of the implemented system in reducing the energy consumptions and also the carbon emission. Okay, this project was developed according to the waterfall model, which is a sequential development approach where progress flow through clearly defined phases. Okay, we start with the analysis, and then design, implementation, testing, and last one is the maintenance. For analysis phase, this analysis guides the determinations of materials and software needed. Specifications like control lines, energy consumptions, and microcontroller types are considered, ensuring reliability, scalability, testability, availability, maintainability, performance, and also quality standards. In design phase, a flowchart is created to map the program's logics, considering control from various sources like timing algorithms, manual buttons input through Arduino IoT Cloud, and also the bypass button. So this block diagram is then developed to illustrate the hardware connections within the Ecopower Guardian system. Implementation phase brings the conceptions of Ecopower to reality. So this phase involves programming and also hardware developments. For programming developments, the flowchart is translated into code using Arduino IDE, which is involved writing functions to handle various tasks. So the code is written to implement the schedule power management based on the predefined timing algorithm associated with the RTC modules, and to toggle the lights and exhaust fan in response to the manual button. The IoT cloud involves the communication between the Ecopower Guardians and the Arduino IoT cloud to receive and interpret commands for remote controls and power monitoring with the code that has been uploaded to the ESP32 via the Arduino IoT cloud. For the hardware development, it involves ESP32 IoT board, current sensor, RTC modules, relay modules, and also the power supply. In testing phase, we start firstly we test the software testing, then we go for the system testing, and lastly is the hardware testing. And last one is maintenance phase. So the regular system check and periodic inspection to verify the functionality by monitoring the power consumptions. And then we updates and bug fix are performed to improve the system functionality, and also components are replaced occasionally for the optimum lifespans of the Ecopower Guardian. So this is the system flowchart, and the Arduino IDE is used for the offline programming, whereby the Arduino IoT Cloud is used to do the online programming, and the remote control and monitoring. Thank you very much from us, and that's all for today.